All right, welcome to another episode of Math with Mr. Young. Today we're working with 7.4 three-dimensional figures. Our standard is 6th grade Geometry A, and our objective is that we're going to be able to describe and draw three-dimensional figures. Our mathematical literacy, we have solid, prism, polyhedron, pyramid, face, edge, and vertex. Let's go ahead and get started. All right, 7.4 three-dimensional figures. Our success criteria is that we're going to be able to find numbers of faces, edges, and vertices of three-dimensional figures. We're also going to be able to draw prisms and pyramids, and to draw the front, side, and top views of a three-dimensional figure. All right, our mathematical literacy, we have solid. It is a three-dimensional figure that encloses a space. A polyhedron is also a three-dimensional figure that is made up of regions that are shaped in polygons. A prism is a type of polyhedron that is a three-dimensional figure. It also has two polygon bases that are parallel and congruent, as well as lateral faces that are parallelograms. A pyramid is also a polygon, but it can't be a circle at its base, and all of the lateral faces are triangles. All right, so again, this will make much more sense as we go forth. All right, okay, so before we get into any of this, I want to talk to you guys about dimensions. Okay, dimensions. Now, for this 7.4 lesson, it's about three-dimensional figures. Okay. Now, in order to understand three-dimensional figures, you first have to understand what two-dimensional figures are, what one-dimensional figures are, zero-dimensional figures. So, I'm going to go ahead and put a dot right there. Okay. That dot is called a vertex. Okay. And vertex was one of your vocabulary words for this lesson. Now, I want to know, how many dimensions is that dot? Does it have any dimensions? Now, again, I want to talk to you guys about this. I'm going to make a little table. So I'm going to go 0 dimensions, 1-dimensional, 2-dimensional, 3-dimensional. Again, we do live in a three-dimensional world. So keep that in mind. So how many dimensions is that this figure here? All right, I'm going to finish out my chart here. And again, this will make a whole lot of sense. We're going to learn, you guys, today. Okay, so I'm going to get very specific with this because I really want you guys to have a deep understanding about what three-dimensional figures really are. Okay. So I'm going to put shape here. So again, that vertex there has no dimensions. Okay. Now you'll see what I'm saying in a bit. Now I'm going to make another vertex. Now, when it's singular, it's called a vertex. When it is plural, they're called vertices. Okay, so now we have two vertices, and if I were to connect them with a line, we call that a line segment. But ultimately, I also want you guys to see that now that we have that other vertex and we have two vertices, this would be known as the y-axis. The y-axis is basically the height. How tall is something, okay? And that's also one-dimensional. Okay. All right. I should have put that on this side actually. So let me move that over on this side because this is going to get in the way. So this is one-dimensional. Okay. So the y-axis is one-dimensional. That is the height. Okay. Now if I were to add more vertices, two more vertices, and if I were to connect them, okay, just bear with me here. I would have a square. Okay. Now this time, again, we do have that y-axis, but the other dimension is known as the x-axis. Okay. And the x-axis is the width. Okay, it's also known as the length okay, but it's the width, and that's also one-dimensional. So if we look at this this box now, and if I were to go ahead and color it, I'm going to color it a color. Let's go with green. I'm going to color the area inside, all the space inside that this square. Okay, and again, what's 1 plus 1? Well, 1 plus 1 is 2. So this square here is what we call a two-dimensional figure. Okay, it's a two-dimensional figure. It's a two-dimensional square because it has a height and it has a width. Okay, now if you look inside the square, the green square, how many units do you see? You see 4. So that has an area of 4 units squared. Now again, notice I said squared because it is technically a geometrical shape of a square. Okay. Now the area formula for a square is area equals base times height. And look here at your base, you have 2 units. Your height has 2 units. So if you substitute now 2 for the base and 2 for the height, oops, 2 times 2 equals 4. So it's 4 units squared. Okay. Now, before, when I just had that vertex here, we had 1 0-dimensional. Okay. So we have 1 0-dimensional. We didn't have any 1 dimensions, 2 dimensions, or 3 dimensions. All right. But, oops. Let me fix that real quick. But when I added those vertices to make that two-dimensional square, well, in this case, how many dimensions do we have now? Well, let me go back. Let's take it step by step. What I really did before was I added another vertex here and I connected it into a line segment. Now, in this case, we have 1, 2 vertices. We had 1 1-dimensional, 0 2-dimensionals, 0 3-dimensionals. Okay, with this figure here, that line segment. All right. So again, please keep up with me. But when I ended up adding those 2 more vertices, we had a perfect square, and then we connected them with line segments. So this time we had 1, 2, 3, 4 vertices, 1, 2, 3, 4 edges, and 1 face. Now keep in mind, all this area in green is called a face of that two-dimensional figure. So we have a face. Okay, we also have edges. Now an edge, okay, edges are the sides of this two-dimensional square here. So we have 1, 2, 3, 4 edges. Okay. All right, so there you go. But again, this whole lesson is about 3-dimensional figures. So far we talked about 2-dimensionals, and if you look over here in this chart that I made, so again, 0 dimensions are called the vertices, 1-dimensionals are the edges, 2-dimensionals are the faces. Okay. Now, again, you have 1, 2, 3, 4 vertices. Those are your 0 dimensionals. 1, 2, 3, 4 edges, which is the I guess the sides of that square, and of course you have 1 face. Oops, I broke my crayon. And the face is pretty much the face of this square here. Okay. Now we're going to go further. So this time I want to introduce you guys to, and this is what makes a 3-dimensional figure here. 2-dimensional, one more time. 1 dimension plus 1 dimension equals 2 dimensions. Okay. And that is going to be your X and Y axis, your width and your height. But to make things 3D, 3-dimensional, just like that. It's kind of like when you guys go to the theater and you guys watch a movie in 3D, you put on your glasses. Well, my friends, when you do that, you actually have the next dimension, and that next dimension is called the z-axis. The z-axis, and that is the depth. Okay, so z-axis, and that is called the depth. And that's also another dimension. So what's 1 plus 1 plus 1? Well, 1 plus 1 plus 1 is 3. So that's three-dimensional. You have a width, how wide is this cube? A height, how tall is this cube? And a depth, okay? So again, that is a 3D object, and if I were to do this, there you go. So again, I'll make this bigger. Maybe I'll put it over here. This is our cube. So far we have 4 vertices, we have 4 edges, but as soon as we have a depth, we have this figure, a 3D cube, okay, 3-dimensional cube. Now, let's count all the vertices here. So we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. How many edges does it have? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. How many faces does it have? It's kind of like this this die here. Okay, you have 1 or 2, 4, 6, 8 vertices. You have 2, 4, 6, 8, 10, 12 edges. And how many faces? So this would be a face here, this 2-dimensional plane. How many faces does this cube have? Okay, so we have 6 faces. So we have 6 2-dimensional faces. And how many 3 dimensions do we have? We have 1, and it's that cube there. Okay, so again, you have your x-axis, your y-axis, your z-axis, x, y, z for a 3-dimensional figure, your width, your height, and your depth. Okay, so there you go, my friends. Now I have a question for you. I want to take this further. So if we add a 4th dimension, okay, these are all zeros. How would that look like? If how would a 4D look like? In other words, I want you to pay attention here. So what I'm asking you to do next is I'm asking you to draw a 4-dimensional cube in a 3-dimensional form on a 2-dimensional plane. Now this paper here is 2-dimensional. It has a height, it has a width, but as far as depth goes, there's really nothing. This is a 2-dimensional plane. This screen, your Chromebooks that you're looking at, is also 2-dimensional. Okay, it has a height and a width, but there's really no depth. Now, the 3rd dimension, the depth, you do have to use 3D glasses to see that. But again, how would that look like? Again, ladies and gents, the bottom line here is this is what it really means when we talk about 3-dimensional figures. You have your x-axis, your y-axis, and your z-axis, your width, your height, your depth. Now really quickly, I want to talk to you about the differences between a prism and a pyramid. Okay, so a prism, let me draw a prism. So this is a type of polyhedron that's also 3-dimensional. It does need to have 2 polygonal bases that are parallel to each other. Okay, so for an example, let's say if we have this triangle here. Okay, so how many vertices do I have so far? Well, I have 1, 2, 3 vertices. How many edges do I have now? 1, 2, 3 edges. So vertices, edges, and faces. Okay. Now again, I want to do the same thing on the bottom, and if you use a protractor, especially the protractor I gave you guys, I should have been doing this a long time ago. You make it better, so you want to take pride in your work. Do your nice work. Okay, take pride in your work. And that's with everything in life. Whether you're building a fence, washing a vehicle, cleaning it out, going to school, going wood hauling, anything. You take pride in your work. Okay, so there's my 2 polygonal bases. Now if I connect these other vertices with the line segment called edges, it would look like that. So there's my 3-dimensional figure. We call this a prism. What kind of prism? Well, look at the base. What shape do you see down there? You see a triangle. So this is a triangular prism. Okay. Now I want you to see the differences between a prism versus a pyramid. A pyramid is also 3-dimensional. But let's count all the vertices over here for the prism. So we have 1, 2, 3, 4, 5, 6 vertices. How many edges does it have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And how many faces does it have? So in the back, I'm going to lightly color this one green. There's one face. In the back, I'm going to lightly color this one black. There's 2 faces. In the back, on top actually, I'm going to lightly color this one blue. There's 3 faces, and I'm going to color the base, the bottom blue. There's 4 faces. And then in the front, I'm going to color this face. So we have 1 in the back, 2 here, 3 faces on top, 4 faces here, and 5 faces in the front. So again, this triangular prism has 6 vertices, 9 edges, and 6 faces, or 5 faces, I'm sorry. All right, now let's look at the pyramid here. Now a pyramid, again, we're going to make a triangular pyramid here. Okay, so far I have 3 vertices. Vertices, edges, and faces. Now again, this is 0-dimensional, this is 1-dimensional, and this is 2-dimensional. Okay, so let me connect these real quick. So we have 1 edge, 2 edges, 3 edges. Now the difference between a prism and a pyramid is that we only have 1 vertex up top. And all these points here, all these vertices, they have these line segments that meet up with just that 1 vertex. So opposed to a prism where you have matching bases, let's call this base 1 and base 2. So base 1 and base 2, they are identical. Okay, they match. Whereas a pyramid, they only meet up to 1 vertex, to 1 point. Okay, now let's count all the vertices of this pyramid. We have 1, 2, 3, 4 vertices. How many edges does it have? We have 1, 2, 3, 4, 5, 6 edges. Let's see, 1, 2, 3, 4, 5, 6 edges. How many faces? Well, I'm going to color the bottom blue. There's 1 face. I'm going to color the left side face orange. I'm going to color the right side face red. There's 3 faces so far. And then don't forget that you have to color the front face. This one right here. In the front. So how many faces do we have? We have 1, 2, 3, 4 faces. All right. So there you go, my friends. Those are the differences between a prism and a pyramid. Now, similarities is that they both are 3-dimensional figures. but at the same time, a prism differs from a pyramid because it has two bases that are identical, and a pyramid does not. So it does have a base, but they all meet up on the front. Okay, so this again is called a triangular pyramid. All right, triangular pyramid. Okay, oops. This is a triangular pyramid. And also, if the look at the base here, if the base was a square and it had one vertex up top, or vertex, and they all meet up there, that would be a square pyramid. Okay, if it was the base was like a pentagon, 1 2 3 4 5, and they all met up at one vertex up top, that would be a pentagonal pyramid. All right, does that make sense to you guys? Same thing for a prism. This is a triangular prism because the base is a triangle. But if the base was a square and the top was also a square and they all met up, and that would be a square prism. Okay, so hopefully you guys are catching on here. So again, the type of pyramid it is, the type of prism it is, look at the base. What is the shape of the base? Okay, whatever it is, in this case a triangular prism. The base here is a square, so it's a square prism. For a pyramid, this is a triangle at the base, so it's a triangular pyramid. The base here for a square, for this pyramid here, is going to be a square pyramid, and the base here is a pentagon, and it's a pentagonal pyramid. All right, so there you guys go, and that's basically it. Okay, so again, just to recap, remember that three-dimensional figures, there is such a thing called as no dimensions, one-dimensional, two-dimensional, three-dimensional, and it's possible for 4 dimensions. It's possible for 5 dimensions, 6 dimensions, 7 dimensions. I mean, it just keeps going. All right, but yes, we do live in a 3-dimensional world, so we're just gonna stop there. Okay, I don't want to melt your brains. So right here again, just to recap, what does it really mean when we say 3D? What does it really mean when we say 3 dimensions? Your x-axis, your width, your y-axis, your height, your z-axis, your depth. Okay, so X-ray, Yankee, Zulu, XYZ, they're all one-dimensional. So again, when you're measuring something, how wide is it? That's one-dimensional. When you're measuring something, how tall is it? That's also one-dimensional. When you're measuring something for the depth, that's also one-dimensional. Your x-axis, your y-axis, and your z-axis. Okay, and one more time, that is your width, your height, and the depth. All right, ladies and gents, that's basically it. And again, just to recap, for 7.4 three-dimensional figures, by now you should be able to find the faces, edges, and vertices of three-dimensional figures. You should by now also be able to draw prisms and pyramids, and also draw the front, side, and top views of a three-dimensional figure. Okay, so basically, as long as you can get this root down, the main concept here, and the real understanding, and you guys got it. Okay, I'll see you guys later.